New instrument used Antarctic ice sheet to probe extreme universe. The payload for Ultra-High Energy Observations, PUEO, is a NASA Astrophysics Pioneers program mission designed to detect the most energetic particles in the universe. The PUEO mission flew high above Antarctica on a long-duration balloon, LDB, and used the Antarctic ice sheet as an enormous detection volume to look for radio signals generated by the interactions of extremely energetic astrophysical neutrinos as they pass through the ice. In addition to searching for the highest energy neutrinos, PUEO could also detect radio signals from high-energy cosmic rays showering in Earth's atmosphere, aka air showers, either as the signals entered directly into the instrument or reflected off the ice below. The sensitivity achieved with the PUEO instrument was a result of technology advancements and careful optimization of the experimental design to enable accommodation within the balloon platform's launch volume. The ultra-high-energy neutrinos that PUEO was searching for carry information from the most extreme places in the universe, including supermassive black holes that accrete matter at the centers of galaxies, neutron star mergers, and other powerful cosmic accelerators. Because these particles travel large distances along straight lines without being absorbed, they provide a unique view of the distant, most energetic universe. Not only will data collected by PUEO reveal the origin and composition of the highest energy cosmic rays, it will also test fundamental physics at energies far beyond those achievable in human-made particle accelerators on Earth. The PUEO mission built on heritage from the NASA-sponsored Antarctic Impulsive Transient Antenna, ANITA, mission, which had 4 successful flights from 2006-2016. Like ANITA, PUEO consisted of an array of radio frequency antennas, an onboard data acquisition system that is triggered by neutrino-like signals and processes and saves the data, and a navigation and command and control system. From its 120,000-foot altitude, PUEO monitored an extremely large volume of Antarctic ice, looking for signals from very rare, high-energy neutrino interactions. The first of NASA's Astrophysics Pioneers missions to launch, PUEO took off December 20, 2025, from NASA's Long-Duration Balloon Facility near McMurdo Station, Antarctica, and flew for 23 days before landing approximately 120 miles, 200 kilometers, from the South Pole. The full payload has been recovered, including the data drives. The PUEO team is currently analyzing the data collected, an undertaking that may take up to a year due to the complex nature of the task. The significant improvement in sensitivity achieved with the PUEO instrument compared to that of ANITA was due to a variety of technology advancements and careful optimization of the experimental design to enable accommodation within the balloon platform's constrained launch volume. Lowering detection threshold with interferometric triggering. At the heart of PUEO's technology advancement was a new type of trigger called an interferometric phased array trigger. The PUEO trigger coherently sums signals from multiple antennas in real time, enabling the instrument to detect weaker signals than previously possible. By lowering the trigger threshold, PUEO could dig further into the noise, and find weaker neutrino and cosmic ray signals than previous experiments. More channels in a physically constrained space. The PUEO antenna collecting area for frequencies above 300 MHz was doubled compared to ANITA, improving the sensitivity to radio emission from particle interactions. To ensure the PUEO payload remained within the allowable launch volume, the team increased the low-frequency cutoff of the PUEO antennas, which enabled them to be even smaller than those used on ANITA. Low-frequency instrument for air shower characterization. To improve sensitivity to extensive air showers produced by cosmic rays and potentially neutrinos, PUEO incorporated a new low-frequency instrument that deployed once the payload reached float altitude. It would have been much too large to fit in the allowable launch volume in its flight configuration. This new low-frequency instrument incorporated antennas that are sensitive down to 50 MHz, and extended PUEO's sensitivity to air showers. Many of the technology advancements that were developed for PUEO may also be applicable for mission concepts under development that would use the lunar regolith as a detector for ultra-high energy cosmic rays, and other potential future radio missions on the Moon. Project Lead, Dr. Abigail Viareg, David N. Schramm, Director of the Kavli Institute for Cosmological Physics and Professor of Physics, Astronomy and Astrophysics, and the Enrico Fermi Institute, University of Chicago, assisted by graduate student, Rachel Scrandes.